Good morning, students. Let us continue the Fourier integrals trigonometric form in Fourier series, and we are going to discuss in this class on Fourier sine transform. Find the Fourier transform of f of t equal to e power minus at. So problem is given as f of t equals e power minus at. We are going to find out the Fourier transform. We have to use Fourier sine transform. The formula goes like this: root of 2 divided by pi 0 to infinity e power minus at, because f of t is given as e power minus at sine omega t dt. So this is the formula for Fourier sine transform. So now we have to use this formula, e power ax sine bx dx equal to, this is the answer. So here a equals minus a according to this problem, and b equals omega. Okay, but here a equals minus a and b equals omega. So you just substitute use this formula. Using this formula, we have e power minus at divided by a square plus omega square. So instead of b, you have omega. So a square plus omega square, and instead of a, you have to substitute minus a. So minus a sine omega t minus omega cos omega t. It's easier. Now I have pulled minus sign out. So I have pulled minus sign out. So that will give me this expression, limits 0 to infinity. Now I can substitute the upper limit. So substituting the upper limit will give me this. Substituting the lower limit will give me this term. So first term and second term. And of course we know that e power minus infinity, 1 by e power infinity, 1 by infinity, 0. So I have written 0 here for the first limit, for the upper limit. And for the lower limit, this becomes e power 0 is 1. So 1 divided by a square plus omega squared. Sine 0 is 0. So 0. Cos 0 is 1. So omega 0 plus omega. So Fourier transform of this function e power minus at is given as root divided by pi omega divided by a square plus omega square. So this is the answer. Now we will go for the next problem. Find the Fourier transform of f of t equals e power minus at, but this time we are going to have cosine transform. So last time we discussed about sine transform. So here Fourier sine transform, but this time we are going to discuss Fourier cosine transform. The same function, f of t equals e power minus at is the same function. So we are going to use root of divided by pi 0 to infinity e power minus at cos omega t. We are going to use cosine transform. So cos omega t dt, we are going to use this formula, so which goes like this, and you have a equals minus a and b equals omega. You substitute corresponding terms that will have, we will get as e power minus at divided by a square plus omega square. So instead of a, you have to substitute minus a cos omega t, plus instead of b, you have to substitute omega, so omega sine omega t. Now substitute the upper limit will give me the first term, substituting the lower limit will give me the second term. As usual, e power minus infinity is nothing but 0, 1 by e power infinity, 1 by infinity, that becomes 0. So I have written 0 here. Substituting the lower limit will give me this. And of course cos 0 is 1, sin 0 is 0. So we can write minus a plus 0. So this will give me minus plus will give me the Fourier transform of f of t e power minus at is nothing but this answer, root of 2 by pi omega divided by a square plus omega square. Now we will solve some other problem. Find the Fourier transform of e power minus ax, but you have to deduce integration 0 to infinity cos sx divided by a square plus a square dx equal to pi divided by 2a e power minus ax. So this time we are going to use Fourier cosine integral formula. So that will give me Fourier cosine integral formula, that will give me, which is equal to root of 2 by pi 2 divided by pi f of x. Instead of f of x, you have to substitute e power minus ax cos sx dx. You have to use this formula. Here a equals minus a, b equals s. So here b equals s here because s is here. So b equals s. Of course a equals minus a. You just try, you will get the answer as this one. So this is your assignment. Okay, you just try, you will get the answer exactly a divided by a square plus a square for this integral. Okay, now taking the Fourier, now this is the answer. So this is the answer. You have to include root of 2 divided by pi. So we have got the answer only for the integral, which is nothing but this. This multiplied by this will give you complete Fourier integral. Okay, so this is nothing but this. Now you just apply this is step 2. Just apply Fourier inversion formula, Fourier integral inversion formula. So that will give us f of x equal to root of 2 divided by pi Fourier integral cos x dx, and of course we have found out this. Okay, so root divided by pi and a divided by a square plus a square. You pull root divided by pi out, so that will give me 2. You pull a out, that will give me 2a divided by pi integration 0 to infinity cos s divided by a square plus a square dx. What is asked? This is asked. Okay, suppose if it is sine is there, then we will have to use sine transform. Okay, sine integral formula. This is cos is there, that's why we have used cos integral formula. So we have now f of x equal to 2a divided by pi 0 to infinity cos sx divided by a square plus a square ds. So this alone is asked. So bringing this term to this side and bringing this term to this side, that will give us pi divided by 2a times f of x equal to this one. What is f of a? F of x nothing but e power minus ax. So this is the answer. See, this question we have to prove that pi divided by 2a times e power minus ax. So this is exactly this. Okay, any doubt? Okay. Now find the Fourier cosine transform of this function f of x equal to x in this interval 2 minus x, x lies between 1 and 2, and 0, x is greater than 2. So we have 3 integrals, and of course this is 0. So don't bother about the third integral. We are going to have only these 2 integrals. Fourier cosine transform is asked. So we have to use Fourier cosine transform formula, which is nothing but root of 2 divided by pi f of x cos x dx, where f of x is nothing but in this interval x. So we have to substitute x here, 0 to 1, and f of x is nothing but 2 minus x. See, 2 minus x in this interval. So 1 to 2. So okay. Now first we will take the first term. So first integral is nothing but I1, which is equal to 0 to 1 x cos sx dx. We will have to use Bernoulli's formula because we have now x cos sx, and of course we know that by Bernoulli's formula u is termed as x. We will have to differentiate. So u prime equal to 1, u double prime equal to 0, and we are going to keep b as cos x sx. So we will have to integrate. So this becomes sin sx divided by s. Again we will have to integrate, that will give us minus cos sx divided by s square. Bernoulli's formula goes like this. We have Bernoulli's formula, and you will have to multiply this term and this term with a minus sign. So we know already. So u b1 minus, okay, this minus is here, and u prime b2. Already one minus is there. So minus plus 0 to 1. Now we will substitute. For wherever you find x, you will have to substitute 1. Wherever you find x, you will have to substitute 0 for the lower limit. So this becomes 1 sin s divided by s, substituting the upper limit, plus cos, you have to substitute, instead of x you have to substitute upper limit. So cos s divided by s square. Substituting the lower limit will give us, and of course x, instead of x substitute the lower limit, that will become 0. So 0 multiplied by anything will be 0. So we have 0 here. Cos 0 is 1. So 1 divided by s square. So the complete answer for the first integral is this one minus 1 by s square. Now we will go for the second term. Integral second term. I2 is given by this 2 minus x cos sx dx. And again we will have to use Bernoulli's formula, and here we are going to keep u as 2 minus x, u prime equals minus 1, u double prime equal to 0. And you will have to differentiate. Okay, here v is nothing but cos sx, and you will have to integrate. So v cos sx, integrating, that will give us b1 equal to sin sx divided by s. Integrating this will give us minus cos sx divided by s square. Okay, now we use Bernoulli's formula. Substitute for u, this is for b1, so b1 is here, minus is here, and u prime is minus 1, so minus 1 we have substituted, and b2 is nothing but this, so this term. Now we will have to substitute the upper limit. Substituting the upper limit will give us 2 minus 2, see 2 minus 2 is 0. Substitute the upper limit, which is nothing but 2 minus 2, 0. correct? Now substitute the upper limit will give us, this term will go off. This term will be cos s2. So cos 2s divided by s square. Okay. Now minus sign is here. We have to substitute the lower limit. So 2 minus 1 is nothing but 1 sin s divided by s, and here it is cos s divided by s square. So we have s square term and here it is s square term. We can combine these two. So I have done the same thing here. So we have, this is s square term and this is s square term. We can combine, or otherwise we can write as it is. And this is for the result of the second integral. So now total integral will give us root of 2 divided by pi I1 plus I2. This is for I1 and this is for I2. Okay. Now sin ss divided by sin, this one will get cancelled. See, sin ss by s, sin s divided by s will get cancelled. And cos s will combine together, that will give us 2 cos s divided by s squared, correct? Last one. And next one will be cos 2s divided by s squared, and this term is here. So here s squared in the denominator, we can combine together, we can write exactly like this, and this is your Fourier integral. Okay. Now Fourier sine and cosine transforms. So we'll have to go with Fourier cosine and sine transforms, because it's cos is here, sine is here. So we have cos term and sine term. We'll have to use cos integral. Here we'll have to use sine integral. According to this one we are going to use. So you have f of x equal to e power minus ax. A is greater than 0. Okay. So we'll have to deduce this one and this one. We'll have to deduce this one and this one. 0 to infinity cos sx divided by s square plus a square ds is asked. Similarly this is also asked. So we'll have to use cosine transform for this one. We'll have to use sine transform for this. Sine transform formula for this. So first we will go for cosine transform. And of course it is given as a is greater than 0. So I have written a is greater than 0. We'll have to use cosine transform. Cosine transform formula is given by this. Instead of f of x, we have to substitute e power minus ax as it is given in the problem. So we have e power minus ax cos x dx. So use this formula. Using a equals minus a and b equals s, that will give us this answer. So that is your assignment. Okay. Now use Fourier inverse cosine transform. So that is nothing but this, where capital F of x equal to root of divided by pi 0 to infinity fcs cos sx dx. Your fcs already we have found out this, which is nothing but this. So we will have to substitute, instead of this we will have to substitute this. So we have substituted here. As such this term, let it be. So now I can pull this term out. Okay. So this will give us root 2 multiplied by root 2 will give us 2, pi multiplied by pi, root pi multiplied by pi, that will give us pi. And you have a divided by s square plus a square cos sx dx. What is asked? This is asked. This is asked. See, a divided by integration 0 to infinity a divided by s square plus a square cos sx dx is asked. Bringing this term to this side, will give us this. So this is the answer. Okay. Now we'll go for the second one. We'll have to use a sine transform. So which is nothing but Fourier sine transform formula is f of x equal to root of 2 divided by pi 0 to infinity f of x sin sx dx. Instead of f of x, we'll have to substitute e power minus ax. So e power minus ax. And use this formula. We are going to apply a equals minus a and b equals s in this formula. We will get this. Again, this will be your assignment. Okay. So this is your assignment. Now we have to use inverse sine transform. Okay. We have to use inverse sine transform. It is ICF, not cos. This is sine. Inverse sine transform. So we have to use. So we have f of x equal to root of 2 divided by pi 0 to infinity f of s sin sx dx. So instead of f of s, you will have to substitute this term. Here it is already we have found out. So you will have to use this term. So that will give us root of 2 divided by pi. This term s divided by s square plus a square. As usual, you just pull out this term out. That will give us 2 divided by pi and this one. This is what asked. So bringing 2 by pi this side, we have e power minus ax times pi by 2. So this is asked. Now we will go for some other problem. Find the Fourier cosine transform of f of x equal to 5 e power minus 2x plus 2 e power minus 5x. Okay, we will try to solve this problem. F of x is given by this, and we will have to use cosine transform. So cosine transform formula is given by this expression, and instead of f of x you just substitute 5 e power minus 2x plus 2 e power minus 5x cos x dx. So we can separately write this first term and this is second term, easy to integrate. So e power minus 2x times cos sx is this will be first term and this will be our second term. Again we will be using Bernoulli's formula. So I have written the same thing here, but you will have to write, you will have to use Bernoulli's formula. Bernoulli's formula, here it is a equals minus 2 for the first term and a equals minus 5 for the second term, and of course b equal to s here, and here also b equals s here. So using this this formula and applying this term, we will get exactly like this. Okay, so minus 2 square, that will give us 4, minus 5 square will give us 25. 5 2s are 10, here 2 5s are 10, we can pull 10 out. So that will give us 1 divided by 4 plus a square plus 1 divided by 25 plus a square, which is times root of 2 divided by pi 10. Okay, that is the answer. This is the answer. Now find the Fourier sine transform of f of x equal to e power minus ax, and we will have to show that 0 to infinity integration x sine mx divided by x square plus a square dx equal to pi by 2 e power minus am. So here sine is given, so we will have to use only sine Fourier transform. Okay, we will have to use only sine transform. Sine transform is given, formula is given by this expression. Instead of f of x, we will have to substitute e power minus ax sx dx, and of course we will have to use this formula. Here a equals minus a and b equals s. So substituting this will give us e power minus ax divided by a square plus a square. Instead of a, you will have to substitute minus a. Instead of b, you will have to substitute s. So we will have this. Substituting the upper limit will give us 0, because here it is, this is 0. E power minus ax, e power minus infinity 1 by e power infinity 1 by infinity 0. Substituting the lower limit will give us e power minus 0, 1 by e power 0, answer is 1. So we have now sine 0, 0, you will have s alone exists, so s I have written here. Okay, s alone, s I have written here. A square plus a square, cos 0 is 1, already one minus is there. This minus, we will have to apply the lower element, that minus is there. So minus plus will give us root divided by pi, s divided by a square plus a square. Now we will have to use inverse Fourier sine transform, which is given by this. Instead of f of x, we will have to use this term, so which is nothing but this, times sine ss dx. Okay, now we will have to deduce this one. So what I am going to do is just apply x equal to m here, putting x equal to m here. So that will give us, instead of x, you just substitute m. Instead of s, you just substitute x. So we have, putting now x equal to m will give us sm. See, sm. Wherever you find x, just substitute m here. Wherever you find s, you substitute x, and ds will becomes dx. So that will give us this expression. Correct? Now e power minus am, left hand side is f of x. So f of x already we have found that f of x is nothing but, in the problem it is given as e power minus ax. Instead of x you have to substitute m. So e power minus am, which is equal to 2 divided by pi 0 to infinity x sine mx divided by a square plus x square dx. Bring